lesson 2.1 of Unit 2, Rational Numbers. Let's describe what a rational number is and review. Rational expressions and rational numbers. Well, they are numbers where your numerator and denominator of fractions are either a rational number or they are a integer of some sort. So basically rational numbers can be put into fraction form or decimals. Okay, we get our perfect square roots here, our perfect cube roots. We get all those kinds of numbers, all the negatives, all the positives. Okay, every kind of number, repeating decimals. The only kind of numbers we don't have in this category are run-on decimals with no pattern, which are non-perfect square roots. They give us a run-on decimal. Okay, so everything we're going to deal with is either a repeating decimal or decimals that terminate or end, or their own fraction form. That's the biggest difference, is irrational numbers cannot be put into fractions. How come? Because a fraction needs to be an exact answer if you convert it to decimal form. Now, even if it's a repeating decimal, it's going to be a rounded answer, but we can write a line over it or a dot over it to say it's repeating. So that still can be put into fraction form. Okay, but if it's a run-on decimal with no pattern, they can never be put into fraction form. That's why we don't deal with them. We only deal with rationals. So, on the top here we've got a couple fractions. When we've got a negative, you're going to notice your negatives will always float to the top in the final answer. Okay? So if we take a look at the first two examples, the first one is considered final answer form. This one is not in final answer form because the negative's still on the bottom. His final answer would be negative 9 over 2. That negative sign is going to float to the top. Okay, as the final answer. Now, the minute we put x's in there, so the minute we start putting variables in our fractions, that means now we've converted from regular rational numbers to now a rational expression. Okay, a rational expression is just a fraction with a variable in it. So, when we see something like this, the first thing you need to be able to do is be able to factor it. Okay, it needs to be able to be factored. So if we take a look at all of these, everything is factored except for this very last one. That one's not factored yet. We will have to factor that one to put it in the simplest form. Simplest form is always in factored form. Okay, let's take a look at exactly some more examples here. So we've got a couple conditions. Okay? So, these are what are considered not rational expressions. So you cannot have these. So the first one is roots of variables. So you cannot have a variable under a radical sign. Okay? Now, that means, in essence, your variable under your radical, it needs to be an even number exponent so that it can come out of the radical. Okay? So that the radical disappears. Whenever there's an odd number exponent, it will stay under the radical, which means it's not considered a rational expression. We can't have it. So if you take a look at this one right here, we've got a hidden 1 on our x. So that means this guy is not a rational expression because that x is in simplified form and he's still under the root sign. That's not allowed. If it was root x squared, we've got opposites happening. Squared and square root are opposites. When you have opposites on the exact same question, they cancel each other out. So the squared sign and the square root sign would both cancel. Your answer for that would just be x. So the root sign disappears completely. Okay? Now that will happen with every even numbered exponent. Because all you're doing when you take the square root of a variable is you're dividing it by the index number. So if I've got root x to the 6, and I want to simplify that, well, that's just going to be x exponent 6 divided by 2. I'm dividing by that hidden index. And that takes it out of the root sign. So, that's just going to become x cubed. Okay? That's how we would do something like that. So you don't see a lot of them. You have to know why they exist and why the one with a variable with the x exponent 1, why it stays under the root sign. It can't come out because 1 divided by 2 is what the radical expression is. Okay? So if you've got x to the 1/2, we know from our first unit that that means root x. Okay? They're identical. They're synonymous. Okay? So because of that, we do not want to have odd number exponents on our variables under roots. Okay? We don't deal with those in this chapter. So when we take a look at the left-hand side one, what's wrong with the left-hand side? We've got a variable who is an exponent. With rational expressions, we don't deal with variable exponents. That's an exponential equation, remember. We dealt with those already. We're done with those. That's not what we're talking about in this unit. Okay? If it looks like that, it's not a rational expression. It's an exponential equation. Or an exponential expression. Okay? So this is exponential, not rational. Just because it's in a fraction form doesn't mean it's automatically going to be irrational. Okay? So now we need to figure out how we define our variables. Variables need to be defined in accordance to what they can't be. Okay? That means whenever we've got a variable on the bottom of a fraction, what can our bottom fraction number never be no matter what? What number can you never divide by? Your calculator will say error, 0. You can never divide by 0. So that means you need to have the bottom number cannot never ever ever be a 0, which means there's a restriction on your variable. That's called defining a variable. We cannot have our variable equal to 0 on the bottom. So when we define it, that means we need a non-permissible value. What can't the bottom be? If there's only one variable on the bottom, well, that x just can't be what number? 0. Because if the x is 0, it makes it undefined. Okay, it makes it error, can't do it. That's what it tells you. So that means the x on the bottom of the fraction here, we would say x cannot equal 0. That would be our non-permissible value. And then we put comma xer. What does that comma xer at the end mean? Well, it means x is any real number. So what it means, though, when it's connected to this x cannot be 0, what that's telling you is that as long as it's not 0, it could be anything. Okay? As long as it's not 0. So we need to have our non-permissible values. What can x not be ever, ever? So, specifically, we always just put our non-permissibles, okay? You're non-permissible, you typically don't have the xer on the end because you just don't want to have it 0. So how do we do that? We make the bottom equal to 0 and then solve it. What our answer is there is what will give our answer on the bottom making a 0. Take a look what that means here. So if we just read what it tells us up here, in short form it's telling us what are the restrictions on the variable, meaning find the non-permissibles. So basically what it's telling you, you're avoiding denominators of 0. We never want a bottom of a 0. Okay, that's what it's telling us. So therefore, our solutions that make bottoms of 0, so that make our bottoms become a 0, they're called the non-permissibles. Okay, so I often call that NPV, non-permissible values. Okay, that's what cannot make your bottom 0. Now, what if there's no variable on the bottom of a fraction? If you don't have a variable in the bottom of a fraction, there's no restrictions. Then it's automatically xer. X can be anything because it's not in fraction form and there's no x in the bottom. So if I take a look at this 10x, well, if I wanted to put it in fraction form, it would look like this. I would put it over 1. That's fraction form. Is there a variable on the bottom? No. So this guy can be any real number. X can be anything. There's no boundary on that one. What about the guy on the right? Again, if I put him on fraction form, he'd be over 1. So is there a variable on the bottom? No. So there's no non-permissible, which means no boundaries. The way we write that, x can be any real number because there's no boundaries. Take a look at the next one, 5 divided by x. What do you know about that one, the way it's written? It's right. When the divide sign is the same as saying this, 5 divided by x. It's on the bottom of the fraction. So here I'm going to have a restriction. So I've got to say, well, x cannot equal 0 there. Okay. All right. Take a look on the bottom of this one here. The bottom of the page, it says x plus 3 divided by x minus 3. It's not defined for x equals 3, so x equals 3 is what we call a non-permissible. Why do they say x equals 3 would be non-permissible? So the way we would write that is x cannot be 3. That's our non-permissible. So why is it not positive 3? How did I get a positive 3 from that? Right, so if you plug the 3 in where the x is, 3 subtract 3 gives you 0. So how did I actually solve it and get the 3? What if it was a decimal number, or what if it was a different number that I didn't know? Well, all you do is you make your bottom equal to 0. So I would say x minus 3 equals 0. Now solve for x. So remove the 3 plus 3 to both sides. X equals 3. So that's your non-permissible value. All you do now is stick a non-equal to sign there. There's your non-permissible value. Because if it is a 3, that makes our bottom a 0. 3 subtract 3. Okay? So x cannot be 3 in this case. What if they've given them in brackets like this? Take a look at these ones. What if they're written in this format? What if they're brackets like that? You solve each bracket separately, exactly. So this one's going to look like this. I would take x plus 7 equals 0 and solve it. And I would take x minus 3 equals 0 and solve it. Okay? Now there's a quick trick to this. Okay? I could do the long way, which is just subtract the 7 to both sides. So x equals 7 would make my bottom 0. That means x cannot be 7, or it makes the bottom 0. So that's one non-permissible value, 7. Over here, add 3 to both sides. X equals 3 would make my bottom 0, which means I can't have a 3 on the bottom, or it makes the bottom 0. So I have two non-permissible values in this equation. Is that okay? Absolutely. You can have way more. You can have a multitude of them. It doesn't matter how many you have. So, how would you list them? You just list them side by side or top and bottom. So I'd say x cannot be 3 and x cannot be 7. Okay, those are your non-permissible values. Now the quick trick. Oh, sorry, thank you, -7. You are right, I missed that negative sign there. Thank you very much. Now if we take a look, the quick trick of this is what I call pull it out of brackets. So if I've got this bracket here, the very first one, I've got x plus 7. If you pull that guy out of brackets, okay, when you pull it out of brackets, basically I'm saying to you, do all of this. If you do all of that, it's going to give you a negative number, okay? So basically all you're doing is taking this digit out and making it the opposite sign and dividing it by the number in front of x. What's in front of x? In this case, it's a hidden 1. So what's my non-permissible value? Opposite sign, -7 over 1, which is -7. Okay? So those are the quick tricks to be able to do that. So if I've got a question that looks like this, let's go with 5x on top of 2x plus 3. Okay? If that's my bottom, and I say, what is the non-permissible value, and you pull it out of brackets, what I'm telling you to do is make this number the opposite sign, so -3, and you always divide it by the number sitting in front of x. That would be your non-permissible value. Okay? Now let's work backwards. If they tell you what a non-permissible value is, and they say, what would your bottom denominator look like then? So let's say they tell us our non-permissible value. They say x cannot equal 5/3. X can't be 5/3. Well, what that means then is that you put it into a bracket. You know you've got an x there. Which number's on top? The 5. He goes at the end. The number on the bottom goes in front of x. It's a sign here, positive. Opposite sign to go back in. Okay, that's working backwards. That's all it's showing us to do. Let's take a look at another one of those. I've got 7x minus 4. What is the non-permissible value? That's my denominator. Let's say I've got x on top. 4 over 7. So x cannot be 4 over 7, okay? Opposite sign of this guy, opposite sign. So positive 4. Guy in front of x goes in the bottom. Okay, that's all it is. Now what if they tell you this? you've got x cannot equal -9 over 5. Okay, x can't equal -9 over 5. So, how are you going to put that back into brackets? We know there's an x there, we have a number in front, we have a number at the end. How do we know who goes where? The bottom goes in front of x, the 9 goes at the end, and now you do the opposite sign to separate them. Plus. Okay, good to go? Alright, let's move on. Okay, on these ones, there's one thing missing. First thing you've got to do, you can never find non-permissible values. You can never ever find them unless it's in fully factored form. That's why we spent time reviewing our factoring skills, because we have to factor everything. So, that means on the bottom here, I'm factoring. Then I can find my non-permissibles. So, I need a diamond, I've got a -6 on top, and I have a -1 on the bottom. What are the factors of -6? 1 times -6, 2 times -3. Which combination gives you the -1 on the bottom? 2 and -3, good. So these two, they're my wings, 2 and -3. So they're the ones that go in the brackets. 2 and your -3. Who goes in front? Just your variable x. Okay, because it's x squared, so you're square rooting it, you just get x in front. Now, can I leave the left-hand bracket like that? There's something missing on the left-hand side. The plus sign, good. You have to connect it with a plus sign, it's a +2. If you sit it side by side, that means multiply. That would just mean that's 2x. That's not 2x, that's x plus 2. Okay? Alright, now I can find my non-permissibles from there. So what are my non-permissibles? So what can x not be in this situation for me to get an answer? -2, except I put -2 where x is, -2 plus 2 gives 0. Can't have it. What else? +3. Okay, -2 and +3. That's what x cannot be. Okay? Alright, let's take a look at b. Is b factorable? What does it look like? It looks like you can do this to both sides, doesn't it? Why can't you? Because of the positive sign in the middle. Okay, because of the positive sign. Now, let's take a look at that question. Let's just erase all this. Okay. So, if I have a plus sign in the middle, let's say I put a 0 for x. If I put 0 there, 0 squared is 0 plus 1. Does my bottom go to 0? No. So is there a non-permissible value for that one on the bottom? No, there isn't. Because you've got something sitting here beside it and it's not in brackets. So that means that if I put any digit substituted for x, if it's negative, it'll square be positive. If you put any digit in there, even a 0, it's not going to make your answer 0 on the bottom. All you're going to have is 0 plus 1 on the bottom, which gives you 1. So your bottom's not becoming a 0, which is okay. So since it's not becoming 0, that means there's no restrictions on that x squared. So that means that x can be any real number. There are no restrictions. So there's no non-permissible on that first one for letter B there. Okay? Okay, taking a look at this one now. Can I start the way it looks right now? No, you may not. You cannot start yet. Again, your favorite F word in math. Factor. You have to factor first. So, root and root. Open 2 brackets because it's a difference of squares. You're opening 2 brackets. Square root of x squared. X starts our brackets. Square root of 9. 3 is at the end. Because it's a difference of squares, separated with a positive and a minus sign. Okay, you're separating the signs now. Okay? What would your non-permissibles be now for letter C? Positive and -3, right? So I take this guy out here, he becomes a negative. Take that guy out there, he becomes a positive. So I would say x cannot be positive and -3. Okay, that's your non-permissible value. Let's take a look at D. Again, D needs to be factored on the bottom. So we can do a diamond on this guy. So we have a positive 16 and a negative 8. What multiplies to 16 and gives us a negative 8? If the top is a positive and the bottom one's a negative, the middle one there, that 8, if it's negative, that means you have to multiply 2 negatives to get that positive top number. So that means both of your wings will be negative numbers. So what times what gives you 16 and adds to 8? 4 and 4, good. So negative 4 and negative 4. So now I know my brackets are going to be x subtract 4 and x subtract 4. Those are my brackets. So what would be my non-permissible value here? Do I have one non-permissible or two this time? Just one this time. So what can x not be here? Positive 4. Good. So this one's talking about creating rational expressions that are equivalent. Equivalent means it's like an equivalent fraction that reduces to give you the same answer. So if I've got this, 5 over 10, is that different from 1/2? No, it's not. It's identical. So since it's identical, am I changing the actual value of the answer by reducing the 5 over 10 to equal 1/2? Am I changing the value? No, I'm not. If you converted those to decimals, you get 0.5, and over here you still get 0.5. So you're not changing the value by reducing it to simplest form. So we have to do the exact same thing with rational expressions. We need to reduce them to simplest form. Okay, how do we do that? That's where we get our common factors. That's why we took a look at greatest common factoring yesterday. Okay, so we do it by common factors. So we are going to take a look at the next couple examples. So this one is asking us to use multiplication and division to write two equivalent forms of that guy. All right. All you've got to do is you're going to multiply it by something or divide it by the same thing. Okay? So if I wanted to make an equivalent answer to that, I could do this. I could put a W on this end and a W on the bottom. Because when I simplified, the W's will cancel, correct? But that's an equivalent expression. I could multiply the top and the bottom both by 2. I could multiply the top by 2 and put a 6 in front and put a 2 on the bottom. Okay? Equivalent, yes, because they would cancel out and give me the same answer. Okay? So there's many different ways I can do this. Do you see anything else you can do that you can cancel out with touching nothing? You notice anything that's the same on the top and the bottom that could reduce and give you and disappear? Right, your x plus 2's. If they're on the top and the bottom, they're going to reduce. If I've got something identical on the top and the bottom, they've given you 1 for an answer. So take a look. If I've got 7x over 5x, your x1 and x1, you're subtracting them, the x's disappear, correct? So we're doing the exact same thing. Does taking that x away change the value of my equation or my expression? No, it doesn't. Taking this guy away is not going to change the value of your expression because anything sitting on top of itself is going to equal 1. So if I take a look at this and I go 15wx over 15wx, you divide them out, 15 divided by 15, it gives you 1. All of these cancel. So basically, if it's the same term, dividing by the same term, your answer is always 1. And 1 multiplying or dividing by anything, does it change the value of it? No, never. That's why we're able to do this. It's like reducing a fraction. If I've got 5 over 10, they both divide by 5, I'm reducing, and I'm going to give you 1 over 2. That's the same thing I just did up here with getting rid of those x plus 2's. Okay? It's the same thing. All I'm doing is the original expression is like the 5 over 10. It's huge. You divide something out, which means take something from the top and the bottom that's identical. They disappear. Reduce it, gives you the same answer. Okay? It doesn't change the value of what you started with. Okay? That's the biggest thing you're trying to understand. Any question on that? How could you use the number 2 here? How could we reduce that one? What could you do to reduce on this one? Right. X minus 1s are on the top and bottom. You can reduce them. Now, what if I had another x minus 1 sitting there? Could I get rid of both of them? No, only one. You can only get rid of one of each. One on the top, one on the bottom. So if you had an extra one up there, you couldn't cross it off. It would still be there. Okay? All right. So one equivalent form, if we cross those off, would be x plus 5 over 2. Absolutely, there's an equivalent form. If I use multiplication, that means I want to multiply the top and bottom by the same thing. That's just going to give you the same answer again. It's just bigger, right? That's like taking 1 over 2 and timesing both by 5. You get 5 over 10. You haven't changed the value. There's still 0.5. That's all I'm going to do here. So what if I take and I add x plus 3 to the top and x plus 3 to the bottom? Have I changed it? No. It's going to be the exact same thing. Because if I simplify, they would reduce. All you're actually doing is timesing it by 1. Because something on top of itself equals 1. So I'm actually timesing that whole expression by 1, which doesn't change the value. So I could have all that. This is equivalent. X plus 5, x minus 1, x plus 3, all over 2, x minus 1, x plus 3. So this would be considered a multiplication one that gives you an equivalent form. This one here, where we canceled out the x minus 1s, that's considered dividing. Okay, that's a division sentence. Because we're dividing or canceling out something. Okay? Now, could you add something else? Could you put something else instead of x plus 3 on top and bottom? Heck yeah. You can put whatever you want. You can put pi on the top and bottom. Okay? You could use your ruler's number, letter E. You can put whatever you want, as long as the top and bottom are the same. Okay? All right. Let's take a look. So when is it actually in its simplest form? Okay? When is it in its simplest form? All right. This is when we always have it in our simplest form. When the numerator and denominator, so top and bottom, have no other common factors except for 1. So the only thing you can divide out is a 1 from everything. Now, I'm not talking about a 1 where you cancel stuff. I'm talking about the digit 1. If only the digit 1 divides out of the whole thing, then you know it's in simplest form. Okay, you can't go any further. Now, if you're doing it to these rational expressions, you have to remember you need to be able to put it in factored form so that you know what the common factors are. Because that's when the common factors on top and bottom can disappear. Can you ever have a common factor that are sitting side by side? They could be identical sitting side by side, but you're not going to reduce them if they're sitting side by side. They've got to be top and bottom, different levels. Okay? You can never reduce something sitting side by side. It's got to be top and bottom. Okay? All right. So it says, if they are equal for all values, even the non-permissibles, which means you take your non-permissibles from the original factored form before you reduce it. Okay? So, all non-permissibles okay, so all your non-permissibles are the same in the original factored form. Whoa. In the original factored form and in the simplified form. All that's telling us is that we cannot find our non-permissibles from our end result answer. We have to find it from our original factored form. Okay? Because if it's not from our original factored form, and it's just from the answers, some of our stuff has already disappeared from the bottom. Correct? And that's not what we originally started from. Okay? So let's take a look at what that's going to look like for us. Here we go. We're going to try these ones and write them in simplest form. In order to write them in simplest form, we need to factor them if they're not factored. If they are monomials on top of a monomial, like letter A, all we're doing is simplifying the digits. So if I take a look at 15 and 20, they don't divide evenly. They're going to give me a decimal if I take 15 divided by 20. So what you're actually going to do is in your calculator, you're going to go 15 divided by 20 and then math bracket. You're going to put it into a lowest term fraction. Okay? So you're going to math bracket that to get a lowest term fraction, which is going to give you 3 over 4. So I know my answer has 3 over 4 simplified. Now we do what we were doing before, where if we've got something on the top that's not in brackets, something on the bottom not in brackets, if it's got the same letter, top and bottom, you subtract the exponents. So I've got a 2 on the x and a hidden 1 on the x in the bottom. How many do you have left over? Just 1. They always go to the top. Okay, they're going to sit beside that 3. They always go to the top. Now you got y's, y1 and y1. What do you know about your y's? They cancel and disappear completely. No more y's left. So you don't write y to the 0. You just don't write y. It disappears. Now you've got a z3 subtracting z1. Z squared's left over. Okay? All right. Now, that can also be written this way. 3/4 sitting beside x z squared. So they might have 3/4 as a fraction sitting beside the whole thing. And that's okay too. Now, if that happens, you have to understand that those variables belong to the top number, the 3. Okay? If it's sitting beside, the variables always belong to the top. Okay? And you will see it both ways. You have to know they exist. If we take a look at the one on the right-hand side, all we're doing to the one on the right-hand side is like common factoring. They're dividing it by the common factor of 2x. So, again, we're going to divide both of them by 2x. So I'm going to erase that 2x and write it underneath both of them. We're dividing by 2x. Okay, now you're going to divide both of them. If you take a look at that 3 and 2 on the first one there, they're not going to divide evenly. You get 1.5. It's a decimal. So again, you leave it as a fraction. So it's going to just be 3 over 2, because that's the lowest term for that one. Subtract your x's. x2 subtract x1 will give you x1 sitting beside it. So you have 3 over 2 x1. Now remember, that could also look like 3x divided by 2. Okay? The x could be with the top 3. Now we've got a negative in the middle, dividing by a positive on the bottom, so it can be a negative. 8 divides by 2 how many times? 4. Your x's will cancel, because 1 and 1 makes 0. They disappear completely. So that would be your final answer. You can't go any further. Okay? Pardon? It's really confusing?
Yeah.
Can't your x's cancel out?
Yeah.
Instead of x squared, can't you go 8x divided by 2x instead?
Okay, hang on. We can do this one more way by factoring the top, so just hang on. You'll see. Okay, let's take a look at C. Nothing in C is factored. The first thing you have to do is factor absolutely everything. Okay? So, just like I showed you in B above, we could have factored the top out. So we're going to do the exact same thing here. We need to factor that top. So, on the top I'm going to have x plus 2 and x plus 4. How come? Well, when you do the diamond on the 8 and the 6, what multiplies to 8 and adds to 6? Well, the only factors of 8 are 1 times 8 and 2 times 4. The 2 and the 4 add to 6. So those are the wings of your diamond. That's what goes in brackets. Okay? If you can visually do it the way I did, you don't have to show your diamond, you don't have to show the work. You can just basically do it, okay? Then you factor your bottom. Now, hopefully you're recognizing with that subtraction sign in the middle there, that it's a difference of squares, because you can square root the x squared and the 4. Okay, hopefully you're noticing that. So I'm going to square root both. So I'm going to get an x plus 2 and an x minus 2. Okay? Am I going too fast for any of the factoring parts? Very, very good question. Somebody has just asked, can we get rid of x squared? And I see it every year on quizzes and unit tests, and they make this problem on the diploma. And guess what? the answers are there as distractor answers, so it looks like you did it right. But it's not correct to just wipe those two off and then factor the top. You're not able, and then, sorry, you could get rid of that X you're thinking maybe or something, I don't know. But you're not able to do that. How come? Because the top is a trinomial. The bottom is a binomial. They're connected together on purpose. So that means you can't take them separately. Okay? So you cannot do any of that. You must factor it into this form we have. Now in the factored form, 2 steps. So first step, factor. Completely. Second step, non-permissible values. You have to list them. Last step, reduce. Okay, your last step is simplify and reduce. So we factored it completely. The non-permissible values. What can our bottom not be now? Positive and negative 2. So we know x can't be positive and negative 2. Perfect. Now my last step, I reduce it. Are there common factors on the top and the bottom in brackets? Yes. You get rid of them if there are. So your final answer is going to be x plus 4 on top of x minus 2. Now a lot of people are going to say, oh no, no, no. Stop, you're wrong. That's going to reduce. Take away those x's and divide that stuff. You can't do that. Okay? The reason you can't do that is for the reason we couldn't do it to begin with. They're connected together like a binomial, which means it's a pair that has to go together. So you can't take those x's separately from the 4 and the 2. Okay? So that does not happen. Your final answer will be that. Okay? You're not able to do those canceling things. The only thing you can cancel are the complete brackets of the pair. Okay? That's how you solve those ones. Let's take a look at letter D. Here we go. We take a look at our top. Our top is sitting backwards. By backwards, I mean the x squared is being subtracted. You always want the x squared first. So whenever you've got your x squared and you need it to be sitting first, you divide everything by a -1, meaning just that bracket. So I'm going to divide this guy by a -1. I'm going to divide by -1. Then it's going to change my top around. Then it's going to look like this. X squared minus 16. They just switch places. And that's what I need to factor. How come? Because if you look at the bottom when I factor it after, I need to be able to cancel things out. And I'm not going to be able to cancel things out when everything sits as an x plus something or an x subtract something. That's not how my original was sat over here. If I would have factored the top here and square rooted, I would have had 4 minus x and 4 plus x. Those do not cancel with these ones that look like this. X plus 4, x minus 4. Okay? They are different. Because they're in the wrong order. So you have to take the correct ones. So for example, this one right here actually would subtract and you divide out a negative. He would actually cancel with that one. And this guy would actually cancel with this one. And they're opposite signs. It looks strange. Okay? But that's because the -1 you have to divide out. That's why you divide out that -1 first. So, we divided out the -1. Now we factor it. All right. Whoa, undo. That's not what I wanted to do. Okay. We need to do our bottom first, though. All right. Our bottom trinomial has the common factors. I can't divide the 2 out, so I need to just do my diamond method, okay? So I'm going to do the diamond on my top. So I've got 24, a times c, 2 times 12, and my bottom is a -11. So I need something that multiplies to 24 and adds to -11. So that's going to be 1 times 24, 2 times 12, 3 times 8, 4 times 6. All you do is you make your factor list. Okay? The bottom number is a negative. In order to get a bottom number as a negative, you need to have 2 negatives to multiply because you need to have that positive number to multiply to get a positive. So both are negative. Now, which 2 number combinations are going to give you the -11? The 3 and the 8. Good. So now I know my wings are -3 and -8. But what are my factors of A? What multiplies to give you a 2? 2 and 1. So you've got to start your brackets now with 2x and 1x. Okay? So now, this 2 and this 1, you've got to divide those wings by them. Who divides by who? 8 divides by the 2, and the 3 divides by the 1. The 3 can't divide by the 2 because you get a decimal. You don't want decimals. You want them to work out as integers, as either positive or negative, no decimals. Okay. Now, remember when you put the answers of the dividing back in the brackets, what's different? They go in the opposite one of the divided by. So, the 2x here, I take that negative 8 and divide it by 2, so I can't put his answer in that 2x bracket. He's got to go in the other bracket. He's going to be a negative 4. So subtract 4 there. The negative 3 dividing by 1 goes in the other bracket, so I have a minus 3. Now I've got my bottom factor. Okay? Last thing to do is factor my top and then simplify. So my top isn't quite factored because I can reduce both of those by square rooting them. Okay? Then you're going to open 2 brackets. So your top is going to look like this. Negative x plus 4, x minus 4. Your bottom stays the same as it was, 2x minus 3, and an x minus 4. Do you see a common factor now that you can divide out? You see it as it reduces. What reduces from there now? Good. The x minus 4s go bye-bye. Now remember, what step am I missing before I do that? Non-permissible values. You need to do your non-permissible values before you cross that x minus 4 out because he's still part of your non-permissibles. So, what would make that bracket equal 0? 3 over 2. Good. So, we know that x cannot be 3 over 2. What else can't he be? Positive 4. Good. There's my non-permissibles. Now I cancel those guys, and then I write my final answer. Negative x plus 4 on top of 2x minus 3. Final answer, you can't go any further. All of it is necessary for your final answer, which means you need to have your non-permissibles. If you forget your non-permissibles, you're losing marks. Okay, let's take a look and see what they did. I got a couple minutes to work on it. So, our original expression, did they factor the top correctly? Yes, they did. Did they factor the bottom correctly? Yes, they did. Good. Did they simplify correctly? Yes. And what is wrong with it? Right. They forgot, because they crossed this guy off, they forgot to include him as a non-permissible value. You can't forget to include that guy. So the non-permissible value is missing that positive 4. That's the only thing that's wrong with that. Okay? How come? Because remember, before you cross things off, you have to have your non-permissibles from that complete bottom when it's factored. Everything from the bottom. That includes that x minus 4, which gives you the plus 4 for non-permissible. Okay? So the only thing that's missing is that plus 4 there. On the bottom on 13, somebody's claiming that these two expressions are equivalent. Are they correct or are they wrong? They are correct. Now, how come? Right, because your x minus 3 will cancel. When it cancels, you're going to get the exact same thing as you started with. Okay? So, yes, they are equivalent. Okay? This concludes 2.1 rational numbers.